All right, last bit of a couple problems we're going to work. This is Try These E in Activity 21, Lesson 2. Letter A is tangent plus cotangent equals cosecant times secant. Well, our first step, like most of the time, is to turn everything into sine and cosine. I'm going to work the side with the addition. Well, tangent turns into sine over cosine plus cotangent is cosine over sine. And we're still trying to get cosecant and secant. Well, the next thing we have to do is add our fractions. We're going to multiply our bottoms, multiply up, multiply up. This is going to give me sine squared plus cosine squared over cosine times sine. Well, we've seen sine squared plus cosine squared before. That's a Pythagorean identity. So we can replace that with 1 over cosine times sine. Well, what's nice is that this 1 goes with 1 over cosine. It also goes with 1 over sine, which are, in fact, reciprocal identities. 1 over cosine is secant times 1 over sine is cosecant. Now, that is not written exactly like the way it is up top, so you want to rearrange this because multiplication is associative and commutative. Commutative allows you to rewrite it, so it allows us to rewrite it as cosecant times secant, which is exactly the same as the top up here. Now we can go in and fill in all of the reasons. I'll leave that up to you guys on your paper. If you're in class, we did it in class. If you were not in class, you can come see me. We can fill them in if you cannot figure it out yourself. All right, try the Z, letter B. My actual problem is cosine squared times secant squared minus 1. And we need this to equal 1 minus cosine squared. Well, I'm going to work this out with the cosine squared and the secant squared because there's just more meat over there that I can actually work with and play around with. All right. So your first instinct, like I've been teaching you guys, has been turn everything into sine and cosine. But we don't want to do that here. We want to get rid of this secant squared minus 1. Well, if you look at your Pythagorean identities, secant squared minus 1 is actually tangent squared. So we can rewrite this equation as cosine squared times tangent squared. And that still is going to have to equal 1 minus cosine squared. Well, now here I can go ahead and write tangent in terms of sine and cosine. I'm going to get cosine squared. At this point, we're going to do fractions to do it over 1 times tangent is sine over cosine. And because tangent squared, both of these are squared. Here we have to multiply our fractions, which you multiply straight across. Conveniently, my cosine squareds cancel out. This leaves me nothing more than sine squared. And if you look on your Pythagorean identities, we'll see that sine squared is actually 1 minus cosine squared. This is exactly what we're trying to get to. So at this point, we're finished. You can go back in and fill in the reasons. In fact, let's just do that. We have enough room here. My very top line, that's going to be my given, because that's what the problem gave me. What I did from the given part to the very first step is I did the Pythagorean identity. PYTH, good enough. Once I did that, I rewrote tangent squared in terms of sine and cosine, which is actually my ratio identity. Once I rewrote it in the ratio identity in terms of sine and cosine, I multiplied my fractions and simplified. So I multiplied and simplified. And then my very last step, I actually substituted in sine squared, replaced it with 1 minus cosine, which once again is the Pythagorean identity. All right, guys, this right here is going to be try these E letter C. The problem itself is secant plus 1 equals sine times tangent over 1 minus cosine. Okay, I'm going to show you the way, not a way I did it in class where I multiplied by the reciprocal, but the way that I originally worked this out. Okay, so my first step is to turn everything into sine and cosine. I'm going to work with the side with sine, tangent, and 1 minus cosine, because that's just going to that gives me more options, more flexibility. Well, sine is already in terms of sine and cosine. So this is going to become sine. We know it's going to just go ahead and put it over 1 times, well, tangents are ratio, which is going to be sine over cosine. And this is all still going to be 1 minus cosine. From here, we're going to have to multiply my fractions on top. Well, when I multiply straight across, I'm going to get sine times sine is sine squared over cosine all over 1 minus cosine. And I'm just going to put that all over 1 because we can do that. That's fine. This is going to allow us to do that little rainbow method that I showed you guys. This is going to give us sine squared all over cosine times 1 minus cosine. Well, this 1 minus cosine is just kind of bothering me, so I'm going to get rid of it. I know sine squared. Sine squared is nothing more than 1 minus cosine squared, because that's a Pythagorean identity. Of course, my bottom still stays the same at cosine times 1 minus cosine. From here, 1 minus cosine squared, conveniently, is the difference of two squares. So I can actually rewrite this as 1 plus cosine 1 minus cosine divided by cosine times 1 minus cosine. Well, your 1 minus cosines, they go away. It makes our life a whole lot easier. So when I rewrite this, up top here, I'm going to end up with 1 plus cosine all over cosine. Now, if you remember, we need to get to secant plus 1. Well, I'm going to take this fraction, I'm going to rework it backwards. I'm going to rewrite it. I'm going to write it as 1 over cosine plus cosine over cosine. I'm going to break each item on top with the same denominator on the bottom. Well, our denominator is just cosine. So I can rewrite this as 1 plus cosine over cosine, and it works out for you. And from here, we just simply do the math. Well, 1 over cosine, that is a reciprocal identity, which gives me secant, plus, and cosine divided by cosine gives me 1. So these end up giving me exactly what I needed to get, secant plus 1. Secant plus 1, and you can go in and fill in all of your reasons. This one has a little bit more steps than before the other ones. However, it's still very doable.